Hello. In this session I'm going to show you how to apply caustics and also how to create transparent materials which are used in combination with caustics so that you can make believable glass, etc. Now first take a few steps in order to add the scene, to add lights to the scene. So first thing that we're gonna do is we're gonna place this light source using spotlight. So we're gonna move it a little bit upward. By selecting this we have like more controls, which is quite handy in order to make sure that the spotlight is always going to look at exactly the spot that we want it to look at. So do something like this, and then we're going to set a few values over here so that we have a good result. So first of all we need to have like quadratic. We set its intensity to 1200 to start with. A cone angle of 40 seems to be okay, and then penumbra angle of, let's say, 10, and then we should add a shadow as well, so using ray trace shadows, and that's it for a start. So let's see what the result is going to look like. So we have something like this. Light balance seems to be okay, so that's all fine. Okay, so first thing that we're gonna do is we're going to apply a new material. Now since we're working with mental ray, we're going to apply mental ray materials, and the reason for that is the following. Mental ray materials are specially designed to work, of course, with the mental ray render engine, and therefore usually they render much faster. So, and they also have like some more controls and give you then also better results. Now of all the materials that you see over here, if you go to the mental ray tab, you see materials. You see this whole lot of materials being provided here. Now most of those materials are very specific, and what we want to use is like a very generic kind of material, and these are the ones that you should use. Those are the Mia materials, Mia material X, Mia material X plus. Now you see three of them which actually are quite the same, except for the change that this one is the latest version and it supports like rendering multiple passes and things like that. So this is best material to use. You can neglect the other ones. So we're gonna add it and we're gonna rename it to glass. So select the object and make sure that you apply the material. So if you're gonna make now a first render of that material, you're gonna see several things. We see a little bit of reflection happening over here. We see some specularity. So basically all parameters are working, and let's store this image. Now glass is consisting out of different properties. Glass is both reflective as it is also refractive. So we're gonna approach it in separate parts. So first of all we're going to focus on reflection, and after the reflection has been done, then we're going to go deeper onto the refraction itself. So let's check the reflection. Now first of all, what you need to know about reflection is it's in fact something which is not added on top of something that you have, that you already have, but it's something that actually subtracts light or energy from other parts. Now to explain it a little bit, diffuse, what you see over here, is actually the energy which is being of the light source, which is being scattered around into all kinds of directions. Now the stronger you make the reflection, the less diffuse there can be, because the total amount of energy shining onto the object from the light source cannot go over 1, of course. So you can't reflect like more light than there's actually light. So let me show that to you, and for that we're going to have to activate several things. We see over here reflection, and over here you see also a tab which is called bidirectional reflection distribution function. It's a complex name, but it's used to have like reflection being different from the frontal face to the side faces. So what we're going to do is we're gonna neglect that all, and we're going to set this to purely 100% for both 0 degrees as well as for 90 degrees. And we're going to set reflectivity also over here to 100%. So if we're going to render out now the result, you're going to see that we have like the pure reflection of the whole environment, and we see also the blackness, of course, because we don't have anything behind us. So the diffuse has completely been dissipated, has completely been removed. Now if we're going to multiply the reflection with a value of 0.5, then you're going to see that we're going to have like half reflection, half diffuse. So this is what we see over here. A little bit of diffuse, a little bit of reflection. Okay, let's go back and set the reflection back to 100. I'm going to store this image. Now, what else do we see as settings over here? Over here we have also glossiness. Glossiness is how polished in fact the surface is. So a glossiness of 1 means that the surface is like perfectly polished. Now you can reduce this and actually make it just a little bit more towards the diffuse. So if we drop the glossiness, and I'm gonna do it already quite a bit, so it's quite clear, say to 0.4, and the glossy samples are the number of rays being used. So if you render that again, you're gonna see that the reflection is not that sharp anymore. It's all a little bit fuzzy right now. So like with other traditional methods, if you increase the glossy samples, you can of course improve the quality, as you can clearly see right now over here at this bottom part. So I'm gonna put this back to a perfectly reflective material, because we're going to assume that our glass is like 100% perfectly polished. Now there are some settings over here which I'm not going to go much deeper in. Highlights only is that you don't have like any reflection, but that you only have like the specularity. Metal material, I'm not too sure about that, but we don't need it actually for our glass material right now. Now we have over here also this bidirectional reflection distribution function. Let's start to play a little bit with this. So we're gonna leave the reflectivity at a value of 1 and gonna go over here. So if you have glass and you can take glass from your shelf or something and look at it very closely and look at the reflections. Now if you look directly onto the surface, full frontal on the surface, you're gonna see you have like just a very small amount of reflectivity. So you can set it to, let's say, a value of 0.1. And if you look at the side, it's very reflective, but it is not like 100% reflective. So we can set that value over here, let's say to 0.9. Okay, let's make first a rendering and then let me explain the other parameters over here. Now if we see the result, again we're gonna see that the diffuse is starting to appear quite a lot. Now this makes it very difficult to judge and to see exactly what's going on over here. So what we will do is we're gonna set like the diffuse color to black, make like purely black, and let's re-render the whole thing again. So now we can make a better judgment on how the reflection is actually looking. And if I look at my glass and if I look towards the light source and move it a little bit away, then what I see is that actually the reflection is really too small over here, and it's just way too dark in the center. So what we can do over here is we can change the curve of that slope. And so if I make like a value of 1, this means like that we have a linear transition from here to over here, which is not exactly what we need, but it shows exactly what the operation does. So now we see that we still have like a lot of reflection and that it gradually dims away. So a good value, I personally think, is, let's say, a value of 2. And this gives you like a more natural kind of fall off towards this reflection. So this all being said, now we have like reflection. You also have like a function called a Fresnel reflection, and this removes like all these controls and gives you like a very sharp and hard reflection pattern. But it's something I don't tend to use. I rather have like full control over the things which I'm doing myself. So I leave it as it is. So the next stage that we're gonna go in is we're gonna check the refraction. So this is the transparency of the surface. Now index of refraction, so if I'm going to look up, for example, index of refraction for glass, so then you get like easily directly this whole list which you can use. So crown glasses, what's being set over here, it's like 1.52 to 1.62. So I'm gonna take 1.55 as an index of refraction. The color remains white, and the transparency, we're going to make it like very transparent. Not 100%, but at least 97% or 0.97%. So very transparent, just not completely. Glossiness is actually exactly the same, as this is going to create like a more blurry effect. So if we see what we have over here, we have like this reflection and this refraction all going on. So if we want to have like a blurry refraction, what you can do is, again like before, set the refraction low, or the glossiness low for the refraction, and let's set it also to 16 glossy examples. And if we render this, you see you're gonna have like glass which looks like it has been sandblasted, at least on the inside, that is. But you see as well that you really need a very high set of samples in order to get something decent out of it. So this is going to take a little bit longer, and it will still take quite a while before you get all the noise away. So again, we're gonna set this value completely to 1, so it's like perfectly clean glass. Now the things that we see over here, first of all, we see like the number of refractions which are going on. So if you look back, we see like a set of refractions, and this is set over here in the maximum trace depth. Now if we would lower this, for example, to let's say a trace depth of 1, and we would re-render the whole thing again, as you can see, this is not going to give you a very good result. It is as if the glass is not refracting quite enough. So you have to make sure that the light beam can bounce enough around the whole scene in order to give like a good result. If you set the maximum trace depth to 8, you're gonna see that we're gonna have like this totally different kind of effect. Something like this. Okay, so this is a little bit for the surface. There are still some things that we're going to control over here about the advanced refraction, and before that we are going to fix something from the light source itself, because what we see right here is that the shadow is only visible over here but not right underneath the glass, and the reason is to be found in the spotlight itself. So if we're going to check over here, use ray trace shadows, we see that our ray depth limit is set to 1, so make it 6 in this case. And let's re-render the whole thing. and now we're gonna see that we're gonna have like a much better shadow result. So the shadow is now fully penetrating the whole surface. Now imagine that you want to have like colored glass. Usually what people think or tend to do is they think, okay, let me first select the material again, that they should color the refraction of the glass. So let's say that you want to have like a little bit this brownish kind of glass, something like this. So if we render this, you see indeed that you have glass which has like this brownish kind of color. You can make this just a little bit brighter. But the annoying thing is that it doesn't take into account like the thickness of the surface. So some parts are like really thick, other parts are like a bit thinner, and it doesn't take that into account. So for example, if we would set it just a little bit brighter, the only thing which it's going to do is it's going to check, did I pass through the surface already several times, and then it's going to apply the color. Now what we want is you want to have like a color which is really absorbing the intensity of the material. So the longer the ray has to travel through the glass, the more it's going to be absorbed. So therefore we're going to leave the color just as it is, and we're going to go to advanced refraction. Now right over here in the advanced refraction you can use a maximum distance, and you can use a color at that maximum distance. So if we set over here our color, and we're going to set the maximum distance of, let's say, a value of 1, then you will see that parts which are thinner tend to have like less effect of this coloring, and parts which are thicker, they tend to show much more the effect of the coloring. And that's actually what we need. So now let's move this glass just a little bit up, because it's reacting not in a very plausible way with the underground. So like this looks a bit better. So this is how we get like the right coloring of the glass, and this is how we get the right material of the glass. Now there's still something a little bit annoying, and that's over here our specularity, because the specularity is, like I said, some kind of faking of a light source. And usually what you want to do is you want to model the light source so that you have like a very precise description of what it should look like. So if we go again to this glass material, the thing that you can do is you can go over here to advanced, and in the advanced tab you see over here the specular balance. So if you pull this back, the specular balance, you're gonna see that the specular over here is going to be weaker and weaker until it eventually is completely gone. So if we would re-render out the scene, we see something like this. Okay, so those are the things we had so far. Just one thing I forgot to mention about advanced reflection is over here that you also have like this maximum trace depth, and that you also have like skip reflection on the inside. Now because this is glass, surfaces are also reflecting on the inside, so we're gonna switch this off, and this is going to take like slightly longer, but it's going to give us a different result, which is going to be closer to reality. So as you can see, this gives you just this slight difference. Now maximum trace depth, we're gonna set this also to 6 or even to 7, so that we have like multiple reflections going on, and the same with the refraction. Let's set it to 7 as well. So what we have over here is now this material, and we want to have also like an idea where the spotlight is going to appear. Now for that we're going to really use a small model. Now this is something we can do in a very simple way, so I'm first going to store the perspective, and let's use perspective 2 so I can move around, and I'm going to create like this very simple shape which is going to be just a plane. Creates a plane like this. I'm gonna make it fairly big, and let's move it to the light source and let's give it more or less the same orientation, something like this. And then just move it a little bit away from the light source. Now I'm going to give this also a material, again a mere material, but this one is going to be the light source. And make sure that you apply the material up, not to everything, just assign the material. And what we're gonna do with this material is we're going to set over here in the advanced tab the additional color. So what you can do right here is you can make like this extremely bright surface. Let's set it to a value of 8. So now we have like this very bright shining surface. Let's go back to perspective that we were working with, perspective 1, and let's see what the result is going to look like. So what we do have now is we have like a real specularity, so we can see like really the light source being reflected inside the glass, and this always gives you like a much more realistic effect. So keep that in mind if you want to light out very realistic glasses. So again, what you can do as well is, for example, let me just duplicate this to show you the effect and place this one more over here. I'm going to rotate this as well, and I'm going to scale it so I get something like this. Perspective. So if we again render the image, you see that you have like really those light sources that you can reflect inside the glass. So I'm going to delete this one for now. Up, wrong one. Okay. So next step that we can do is, since we now have our material, is we can start to see whether we can have our photons flying around. So that's the next step. We therefore have to adjust a few things into our scene. Now first of all, the thing that I'm going to adjust is our light source. Panel, come back to this perspective, selecting the light source, the spotlight right over here, and what I need as well is right over here the render settings. So in these render settings we'll go to indirect lighting, and you always have to wait a little bit, and then it pops up. So we have like all these tabs. The one that we're interested in is over here, Caustics. So activate Caustics right here. So we see like a set of properties that you can adjust: the radius, the scale, merge distance, box, etc. And at our spotlight, if we're going to check the mental ray, you see over here caustic and global illumination. So you can make sure that the light source is going to emit photons. So what do we have? We have photon intensity with the exponent, which is actually the same like the fall off, something like the decay rate that you see over here from the light source. You always have to keep that at a value of 2, so to make sure that it's always like this inverse square decay. And then the number of photons being shot into the scene. So what we're gonna do right now is we're gonna enhance this number of photons just slightly, that we have 100,000. This is still going to be fast enough. And the other thing we're going to do is we're going to up the scale for the caustics. So the value is about 7. Now we can also change the photon intensity over here, but if you change the photon intensity, then it's also going to affect the global illumination. So with the scaling over here, you can have like different control for the caustics on its own. So let's see what the result is going to be like. So first it's generating all the photons, and then we see the very first result. Now if we see what's going on over here, we see that nothing much changes. We see that the photons are going straight through and that they're not being bent by the material. So that's something that we want to address. So first thing that you need to do is go to the material itself of the glass, and what you can do right here is, if you look at the advanced refraction, you can activate over here refractive caustic. So make sure that you activate refractive caustic. If we re-render right now again, the shadow is being calculated in a different way, and we see also that the photons are reacting in a more natural way right now. So this is giving us now already like a fairly good result of what it's going to look like. You see also the caustics are being colored by the coloring of the material. So these are now our next steps. What we're going to do is we're going to up and increase the quality of these photons. Now something very important to remember is that if you rendering those photons, the higher you go in quality, the more time they will absorb. And if you then want to tweak your renderings after, for example having better anti-aliasing, etc., then you don't want to recalculate your photon map every time. So what you can do with caustics or with global illumination or photon volume, all those things in general, what you can do is you can generate a photon map. So that's what we're going to do. And the name for that you can take whatever. Take for example glass, and let's call it test. And the type of map that you're going to create is a P map. So a photon map. What we're going to activate as well is we're going to activate the map visualizer, and this is going to allow you to see it directly into the screen. I see activating it changes the name, so I have to type it in again. So glass test. So now it's going to rebuild the whole photo map. Now what we see already over here is that we have with these few photons, we don't have exactly the result that we want to have. Now first of all, let's go over all these kinds of settings that we have right here. First of all, we have the radius of the polygons, and the radius should be actually quite small. So let's change that to a radius of 0.1. And if you use a radius of 0.1 and we're going to render the results, you're going to see that all the photons are going to appear as being very small. So let's store this. Let's re-render the whole thing. It's now calculating the photon map. And now we see all these photons appearing and being like very small as well. And the smaller you create those photons, the more light they seem to emit. They're going to appear brighter. So let's make this to 0.5, I mean, and let's re-render them again. And now you see we have like all these very small and very bright sparks and spots. So in order to get like a very good result right now, and we see what we're dealing with, we have like all these photons, and this is going to give us like a fairly decent result. Now we're going to up the amount of particles quite a bit. So what we see right here in the scene is all the photons which have been cast directly into the environment, into the scene. Now these are just a very few. Now for the quality that we need, we will have to shoot much more into the environment, so that actually that we're not going to see like all these small details anymore. So the thing that we're going to do is we're going to up a few values. So first of all, we're going to leave this as it is right over here, and let's go to the light source, the spotlight, and we up the caustic photons, what we see right over here. So right now we have 100,000. Let's up it to 1 million points, and let's see what the result is going to be of that. So if we start to re-render, you see that it already takes much more time, so I'm going to pause the video here. And as you can see, this already gives you a much better result. But it's also going to give a few problems. And the problems is the density of the points that we see right over here. So if we go and check this result, you see you have already like this massive amount of points. And this is something we need to remedy as well, because if we want to store like every photon being shot into the scene, then we're gonna have a problem with storing and keeping it into memory. And therefore what you can do is you can use a merge distance. And merge distance allows you to merge the photons together into like one big part. Now usually I take like 1/10 of the size of the radius of the whole thing. Now I'm not going to make this light source so sharp, and now we have like a perfectly sharp shape over here, and this means that our caustic is going to be like incredibly sharp as well. And this is something I tend to avoid, because we have right here this very large light source. So let's up this radius over here, and so we can make this also slightly larger. Let's set it to a value of 0.8. Now since we have like a merge distance, a minimal distance in which all those photons are going to be merged, what we can do right now is we can up this again. So what we're going to do is we're going to shoot now about 10 million polygons. Now what's going to happen over here with this merge distance is that all these polygons that or all these photons which are going to be merged are going to add all their energy together. So for example, you could have like 1 million photons being over here, with each a value of 10. What you could have on the other hand is like if you merge, that you have just 10 photons with each a value of 1 million. So it's going to add all the energy together. So that's what we're going to do right now. So we have upped over here the caustic photons. We've made sure that we have like a merge distance. And what we're going to change as well is over here the caustic filter type. We're going to change it to Gauss. This is always going to give you a better interpolation. And so let's render this again. So now we have generated this high quality caustics effects, and if we're gonna look closer we see all these points, but now we see that they're on a very regular pattern. So they have maintained like a minimum distance towards each other. The ones that were closer are now merged together and they've stored all their light intensity. And this is exactly what we need. So what we can do right now is we can switch off the rebuild of the photon map. And as you could see, if you see at the render time, we had a render time of 10 minutes 46 seconds to render the whole result, including photon maps. Now if we do like a new rendering, and let me go back to the right perspective view. If we re-render that scene again, as you can see, it now only takes 7 seconds. It doesn't have to recalculate anything at all. So this is good. Now there are still things that we can adjust while having this point map in here. First of all, you can still adjust the scaling. So if we make this much more intense, let's say a value of 14, we can still render this effect and see what the result is. So as you can see, these are things that still can be adjusted. Now there are other things, and let me scale this immediately back a bit because it's just a bit too much, but I'm going to take an average. The other one was just a little bit too low. The other thing that we can still adjust is the radius. For example, let's set it to 0.2 and re-render this effect again, and we have like a bit of a blurrier result. Let's increase it again to a value of 1 so that we can see the result. No, that doesn't affect the scene at all. Other things such as the radius and the merge distance, they can't be adjusted anymore. So it's only like the scaling value that you can still adjust. So now that we have done all this, now we can start improving like the render quality. So if we go to our quality, we can start to adjust the anti-aliasing, and I'm going to go immediately to custom sampling so that we have again control over the minimum and the maximum sampling, and that we can see what the result is going to be like. So this starts to look much more crisp, much more interesting, and we see much better results. Now still there are some parts which are still missing a few details, so I'm going to do a few things. First of all, I'm going to activate the jittering. I'm going to deactivate the sample lock. I'm going to increase the samples, and I'm going to set the anti-aliasing contrast a little bit lower, so 0.5, so that it starts anti-aliasing much sooner. So let's keep this result already, and let's continue. So this just takes slightly longer to render, but we can clearly see the difference in quality, especially the borders give a clear difference in result. And also over here with the fine detail, we still have like much better results right now. So now we're getting really closer to finalized quality. A few things still needed to be adjusted. Are the soft shadow. So let's select the light source, that's still selected, and I'm going to increase the shadows over here. I'm gonna give it a size, let's say a size of 2, and let's set the amount of shadow rays to 16 to start with. And let's see what this result is going to look like. This is giving us an enormous soft shadow, and this is not a good idea because now it's really in stark contrast with the caustics that we have over here. So that's something we still need to address. Let's tweak this, and here I made a mistake, so now it took us 44 seconds. Again, I have to lower right over here the sampling rate so that we have much faster feedback. So I'm gonna try with a value of 1 and see what this result is going to look like. This starts to look better. I'm gonna make it just slightly less, 0.8. And this is a little bit the way how you start tweaking the whole thing until you get like a nice finalized result. So now that we know that we have everything there, we can go back up, and I'm gonna set even the minimum sampling level to 1 so that at least 4 samples are going to be taken, so that I'm sure that all the little details are being taken into account over here. This result is still giving us a little bit noise around the shadow over here, so last pass I'm gonna increase the shadow rays over here to 32, and that probably will give us shadows which are acceptable. Okay, so now we have a good result. So we have like the soft shadow, we have our light source that we see, we have our glass which is slowly dissipating the deeper we look through the whole material. We see our caustics nicely, but we see also over here a little bit this rim effect. Now if you want to improve this, you also have to increase the resolution of the geometry. So this is still something that needs to be addressed. So now I changed the tessellation of the object, which you can find over here. So as you can see, the object has been selected, and over here in the attributes editor I changed the highest quality, I changed the U division factor and the V division factor. I set it to fairly high levels. Before it was 10 by 10. And after this change you can see that the caustics have resulted in much smoother end results, something we finally can use as professional results. Okay, in this example I'm going to show you how you can add, how you can create glass with a liquid inside. Now I've created this object in Houdini, so it's an imported object, and I've added already some of the materials. I'm going to explain you how the setup of those materials are, but almost most importantly how the model has to be built, because there's a change of thinking if you want to create something like that. So if we look over here in the side view, and let me just zoom in over here, and we see like the geometry and the liquid inside. Now what I did was I created in fact 3 objects. Perhaps I'll do it over here, orthographic from the front, and let's see over here in wireframe so that we can see it clearly like that. So the wine glass exists out of several objects. We have the outer glass that we can see over here, and then we have the wine, the top part of the wine, which is making contact with the air, and then we have the inside of the wine, which is making contact with the glass itself. These three have to have all different surfaces. And that's really important. Now I'm going to explain to you how this works. If you want to calculate index of refraction from objects, you always have to think on how diffraction happens depending on the medium light is traveling through. So over here we have air, and air we can say that it doesn't have any refraction at all, or at least not at this level. And when it touches the glass, then we have like a refraction index of 1 with a refraction index of the glass, which is 1.55 in this case. So the thing which is going to happen is, once you want to calculate what the refraction index is going to be, what you do is you divide the incoming index of refraction with the outgoing index of refraction. So in this case you would get the air and the glass, which is 1.55 divided by the air, which is 1. And in this case we would get exactly the same result. So this would result in, again, 1.55. For the wine on top of here, this is also in direct contact with the air, so it counts as exactly the same. So that 1.33 is going to be divided by air, which is 1, and this is going to result in 1.33 again. Now the special part is going to happen over here with the wine inside, because it's coming from the glass, which has an index refraction of 1.55, and it's going in the wine, which has a refraction index of 1.33. So what you now have to do is to divide 1.33, the inside, by the outer layer, 1.55. And so in this case we're going to get something around 0.8. So it's a negative refraction index that you're going to get. And this is how you have to calculate about those things. So whenever you want to make a change from surfaces, for example, because a liquid is inside of a glass, or perhaps other materials are still inside, and you can do that also with air bubbles inside, then you always have to change the refraction index, and you always have to make the calculation from the incoming ray to the outgoing material. So this is what I did. So I created exactly 3 materials. So we have wine, and if you check the refraction index, we have 1.33, you have glass 1.55, and the inner wine has like a negative refraction index. So let's make this first rendering. So if you go over here and let's check into perspective view, like over here. So I'm gonna make a quick render. Now what do we see? We don't see anything at all. In fact, we see actually only the outer layer of glass, and we don't see the red wine inside. We don't see anything. We don't even see the foot of the glass itself. So what went wrong over here? Well, the thing is, these objects are imported, like I said, from Houdini, and by default Maya has a strange setting being changed, and that's something you can find over here in the render stats. So if you select the object and you go to its shape and then go in the folder over here, render stats, you will see that visible in reflections and visible in refractions is switched off by default. So you have to activate them for all of those. So once you do that and you make a new render, we're gonna see a different result. So now we see the glass with the liquid inside, with the red wine inside. So the only thing we need to do is now to adjust a little bit the intensity of the material, because this is more wine in combination with water, and I don't think we want to drink something like that. We want to have like really pure wine. So what I'm going to do is I'm going to change a few things. First of all, I still think the glass is way too reflective because we see the black part too much. So these are some of the parameters that I'm going to change. And again, I'm going to do this in the materials. Let's put it over here, the glass, and let's see for the reflection. Where was it? BRDF. So I'm gonna change this and make this like a 0.3, and this can be 9.7, something like this. And the curvature is 2. I'm gonna make this a bit higher. That's gonna set it to 3. And the same thing I'm gonna do for the wine on both cases. Now the other thing we need to do is to make the wine a bit thicker, because now the maximum distance is set to 1. So let's set it to half of that distance. And now let's make a new render about it. So this gradually starts to look a bit better. There are still a few things that I can do in order to make it look really much better. Again, I think still it's way too thin, so I'm going to lower it again. And as you can see, it's also for me like a lot of tweaking. You need to get like an idea on what the values are, so remember, always keep the rendering quality as low as possible, that you have the fastest results. And this is slowly getting closer to exactly what we want to have. This is more like a rich, good wine. So I'm gonna add a few things. I'm gonna change, for example, how the light is being placed over here. So let's go to a different perspective. And you might hear like a few other sounds, but that's because I have a living family walking around, and of course they do make sounds. Okay, so let me just change this a bit, rotate this a bit, and I'm going to also change it like over here, so we get more or less a shape like this. And I think I'm gonna put it right here behind. I think I might have destroyed the original alignment. It's always nice when they make washing machines with all these funny noises. Okay, so let's have like a new render. This looks fairly interesting, although I'm not going to place it like that. Perhaps I'm going to move it a little bit more to the side. Something like this. Let's see what the result is going to be of that. And as you can see, so slowly, if you take a good look at how they light in commercials, how they do the lighting of wine glasses, etc., you can start to play with it. Now, I'm not going to go much deeper onto this because I would have to change a little bit of the environment settings over here and also add some new light sources. But it was mainly to show the effect of what the wine was going to look like. Um, so this part has now been set. Again, the thing which is always very important not to forget, if you want to have like proper caustics, is to select the materials and to add over here refractive caustic. Make sure that this is switched on. Another thing which I can add is over here, skip reflection on the inside. Now if you activate this, you're gonna get like more reality of the surface. So I'm going to skip reflection on the inside for the inner wine because it's not happening over there, but it certainly is happening with glass, and it certainly is happening with the wine itself. So if you're gonna check out the new rendering, probably we might see some differences. So let's check if we see any differences. And yes, we do. You can see it very slightly, but you see it over here on the glass on the top, and we see it also over here. So normally if you want to make it like much better, even more realistic, you have to increase the maximum trace depth. Let's set it to 9, and let's set that for all materials to 9. And we're talking about reflection right now. Now if you want to have that effect, don't forget to also add right over here in the ray tracing that you have right here enough effect. And in the beginning we still had like only one set of reflection, so this is probably going to give like a huge difference. So let's see what this result is going to look like. So now suddenly we see over here the reflection of also part of this being reflected around a few times in the glass. So if we check this with the previous, this is quite a dramatic difference, and this is going to give us a much more realistic result of what the glass is starting to look like. So we can see it also over here on the interior, slowly all these kinds of effects. Okay, so now our glass is ready and set up to create the caustics. So I'm going to pause the rendering and I'm going to calculate the caustics for now. So again, with like this huge number of caustic photons, the things that we see over here, hang on, where is it, mental ray, mental ray, mental ray, and there we have the caustics, and we have to activate the caustics. We can still use the same settings that we did before, rebuild the photons and enable map visualizer. So let's start calculating this, and I'm gonna pause for now. So now we do have a rendering with some caustics, and as you can see, that seems to work all very nicely. So the only thing we need to do is to switch off the rebuilding. Enable map visualizer is not necessary, and then the only thing we still need to do in order to get like this fine quality image is to improve again the quality level. So minimum sample leveling of 1 I'm going to use over here for all the fine detail, maximum sample leveling of 3. I'm going to bring this down to 0.5 as NTS in contrast. And so this will be probably the last render, and then we have our perfectly good looking wine glass. Okay, just forgot to set one parameter over here, so I still have to fix that one. The shadows, the number of shadow rays is going to be about 32. This is going to be sufficient, and that's about it, I think. Well, if you're really picky, you can see like some details going wrong over here, perhaps some details still going wrong over here. So I could still increase a little bit the anti-aliasing contrast. That might fix those problems. Or I can just also up again the minimum sampling level, setting it at least 16. But this is again drastically going to increase the rendering time. But just to show you again the high quality that you can get from that. So I'm gonna leave it like this, and I'm going to re-render the frame, and that probably will be it. So okay, the image has rendered. We have now a render time of 6 minutes 11 seconds, and you can clearly see the big difference, of course, of the previous one. And we have like a fairly decent glass. So this is a bitty approach. Now, of course, this is not like a 100% realistic wine glass, because there are many other very small details we all should add. But this is at least giving you an indication on how you work with those transparent materials and how you work with caustics. And this concludes this lesson.